Okay, we're going to talk about a special kind of function called the greatest integer function. So we have a couple different symbols that we use here. So we have y equals int, which stands for integer, so just int of x. Sometimes we see an x in this double square bracket notation. So that's the symbol behind it. Let's talk about a definition first. So the greatest integer function, this takes on any real number input, so that means our domain could be any real number, and it's going to return the largest integer. That's why it's called the greatest integer function. It's going to return the largest integer that is less than or equal to it. So before we look at this graph here, let's look at a few examples. So if we were to put in 5.3 into this greatest integer function, well, the largest integer that is less than or equal to 5.3 would be 5. The largest integer that is less than or equal to 5.9 would also be 5. Okay? 6 would not be the largest integer less than or equal to it. Okay, it has to always be less than or equal to it. If we put 4 into this special function, okay, we get 4 because 4 would be the largest one that is less than or equal to it. Okay. Negative 3.2. If you think about a number line, all right, negative 3.2 would be right about here between negative 3 and negative 4. And the largest integer that is less than it, all right, would have to be negative 4. Okay. 0.1 is another example. Put 0.1 into this function. The largest integer that is less than or equal to it would have to be 0. So if you were to look at the graph of this, now first of all, let me back up for a second. The range here, this is kind of a unique situation. It only takes on integer values. So you're never going to see decimals or fractions for your y values. Only takes on integers, right? It's called the greatest integer function for a reason. So you need to know what this graph looks like. It's composed of a bunch of jumps here. Notice we have several closed and open circles. All right, we can't have two closed circles on top of one another. Obviously, it would not be a function if that were the case. Okay, but you can use this graph to find any needed value. So, for example, if we wanted to figure out something like, let's look here. This is 1, 2, 3, and 4. All right, if we were to plug in, if we want to try to figure out what 4.7 would be. Okay, so 4.7. Let me go out one more here to 5. Oops, I didn't make my graph big enough. But if I had, all right, 4.7 is right here in this area. Okay, if we were to look up, you would see that the graph would go over one more like this. Okay, 4.7 would fall on this piece right here, which would have a y value of 4. Okay, so this would equal 4 since that is the largest integer that is less than or equal to it. Okay.